Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 9 academic students. It's number 5 in a series of videos where I provide a few more EQAO type questions for practice, review, and study purposes. This video we focus on scatter plots. So in the world of scatter plots, we're going to talk about finding the trend or expectation for a scatter plot, finding the line of best fit, and using an algebraic model to represent the line of best fit. So let's look at a quick question. It says Duncan records the outside temperature at noon each day. He also records the heating cost per day. The graph shows a scatter plot and a line of best fit for his data. So you can see that the scatter plot was originally just the dots, and then someone drew this line representing the line of best fit, and you can see that it's a pretty good line of best fit. Oops, because about half the dots are above and about half the dots are below. And it says, by approximately how much does the heating cost per day decrease when the outside temperature increases by 5? So the horizontal axis is outside temperature, and I want to see what happens when the outside temperature increases by 5. So when I look at the horizontal axis for outside temperature, I see that 5 units is exactly one of these grid boxes. So when I go, for example, from 0 degrees to 5 degrees, right? I've increased by 5 degrees. And in a vertical sense, I have gone from, well, here, wherever that is, to about here. So how far have I gone? Well, looking at the vertical scale, and this is a place where maybe I'll use my magic pen. So if you look at the vertical scale, we see that again, in a vertical sense, it's one box for 5 units. So these two lines that I've drawn for emphasis don't even appear to be a full box apart. It looks like it's less than 5, more than half. So I'd probably make a guess that it's about 3. And let's look at a different part of the graph and see if it makes sense elsewhere on the graph. So again, I want to look anywhere where in a horizontal sense we increase by one grid line or one box. So for example, from here to here. And again, I'm going to draw a straight line just as a reference line. Make it fit a little better. So there's a reference line for that. And here's a reference line for that position. So, and again, let's use my magic pen and zoom in. Oh, that magic pen didn't work. Give it a second. Okay, let's try magic pen. There we go. So again, in a horizontal sense, I went from this grid line to this grid line, which means I went up by 5 degrees. And in a vertical sense, I went from this red line to this red line. And again, you can see that I'm not going a full 5 units vertically. I'm going maybe 4 or 3.5. So my guess is by approximately how much does the heating cost per day decrease, is it looks like about 3 or $3.5. And I knew it was dollars because I just looked over at the graph and realized the vertical axis is dollars. So by about $3 or $3.5. So, you know, if I had to show my work, I would show my work exactly the way I did here with these lines on the graph and some indication that I'm reading the graph. So that was just a quick review of how to look at scatter plots, etc. So here's another question. It says data on distance traveled and the number of hours are shown on the graph. The line d equals 10n plus 30 is also shown. So these dots represent the data between distance traveled and number of hours. And then someone drew this other line, d equals 10n plus 30. Which equation best fit represents the line of best fit for the data shown? So ignoring that d equals line, let me draw a line of best fit for the data I have. It looks something like that. So again, I wasn't really trying to connect the dots. I just wanted to find a line that seemed to fit well, and it just so happened that some of the dots got connected. And it says, which of these best represents this line? So we've gone now from a question about scatter plot and line of best fit to a question about understanding the equation of a line. So for example, the line that was given to me, d equals 10n plus 30, that tells me that this is a starting value of 30. So my starting value is below that. So I have to have a starting value less than 30. So I'm going to cross A off because it has a starting value of 33. The next thing I notice is that the steepness of my line is less than the steepness of the given line, which means I need a slope that is less than 10. So this is 10 exactly, and they're not parallel. This is more than 10, so the only correct answer could be this one, because it has a smaller slope, it's less steep, and the starting value is lower. So let's look at another scatterplot question. It says the average March temperatures for 6 Ontario communities are plotted according to their latitudes on the following scatterplot. So we don't know what the communities are, but 42 degrees west, 44 degrees west, Toronto's at about 46 degrees west, in case you're interested, and so on. It says the city of Kenora has a latitude of 50 degrees and a March temperature of negative 6.3. Does the community of Kenora follow the trend of the data? So the trend of the data. So make sure that you know that when something is talking about the trend of the data, it's talking about the pattern that the data follows. And in grade 9, what we do is we think about drawing a line of best fit. So to find the trend of the data, you draw a line of best fit. And again, there's no reason at all why a line of best fit has to go through even a single point. You just really want to try to make sure that some of your points are above and some are below. So for example, if I draw this line as a trend line, then you can see I've got some points above and some points below, and it's not a bad trend line. So let's add the city of Kenora to the graph and see if it fits the trend or not. So 50 degrees Fahrenheit and negative 6.3 is right about here. Boy, that sure seems to fit the trend. Okay, so I definitely think that based on what we've just done, I would say that yes, Kenora fits the trend. If I had to justify my answer, I would say refer to the line of best fit as graphed. Good. Why does it keep doing that? Anyway, here's another good question. Wing length. Wing length is a reliable method for determining the age of young birds. Below is an example of data for a particular species. Determine the age of a bird with a wing length of 3.6. So using a grid is always a good idea, at least to help visualize. Now I could start by finding the first differences, but since they've given me a grid, I'm going to start by graphing the points. It just makes sense to me. So I've got a point at 1.54, another one at 3.18, 3.2 and 10, 4.1 and 12, 5.2 and 16. So again, what I've just created is a scatter plot of the data. And how do you use a scatter plot of data? Well, for example, if I want to now use this data to predict something that's not a data set, so 3.6 is not part of my data set, so I need to predict what wing length 3.6 will mean. And the way to predict is to follow the trend of the data. In other words, let's make a line of best fit. So here's my line of best fit. And again, I wasn't necessarily trying to go through any points. I just wanted some points above and some below. So I've graphed the points, drawn a line of best fit, and now I can read my graph. I need a wing length of 3.6. So I'm going to go on my graph. Oops, get rid of that. To where 3.6 would be here or a little bit higher. So 3.6, let's say there. And then, and again, this is something that's actually easier in real life with an actual ruler. Then I'm going to read over here and figure out how old that bird would be. So according to my graph, my lines, that I have an age of just over 10 days old. So I would say just over 10 days old. I would probably maybe fudge it and say 11, just because 3.2 is 10. So maybe I'd want to eke that up a bit. But really, as long as your graph is done correctly and you've shown the line of best fit, then it doesn't matter if you're absolutely right, as long as your graph is reasonable and makes sense. So don't forget that if you want to predict what a data set will look like or what a point in your data will look like, you draw the scatter plot and draw the trend line, and it's with a trend line that you predict. So I think there's one more question here. It says, Alvin is researching the population of Canada. He finds data for the year 2001 and predictions for every 5 years after that, as shown below. Determine an algebraic model for Alvin's data and use it to make a reasonable prediction for the population of Canada in 2036. Okay, so first of all, what's an algebraic model? Well, an algebraic model is fancy math vocabulary for find an equation. In other words, find a line of best fit and find the equation. That's what an algebraic model is. Use it to make a reasonable prediction for the population in 2036. Okay, so our job is going to be to find the equation of this data. Now, I could try to find first differences, but I can tell very quickly that my first differences are not going to be perfect. And again, since the graph is here anyway, I'm going to draw the graph. Now, I want you to notice right here, this little thing, just in case you don't know why this is here. It's important in good graphing that I went all the way from 0 to 29 in 2 boxes. And if I didn't have this little skip jump here, I'm not sure what it's really called, but if I didn't have this fold right here, then it would say, it would go 29, and then would have to go another 29, so this would have to be the point 58. So what that fold does is it lets me skip a bunch of numbers while keeping a scale that makes sense for my data. So it makes sense to only see from 29 to 37, and I don't need to see all the numbers before that, and that's what this little fold symbol does for me. So use it when you need it. It's a good thing to do. So let's put these points on. So 1 year, oops. So 1 year after 2000, so 2001 is 31.1 million. 6 years would be 32.2. 11 years is 33.4. 16 years is 34.4. 21 years is 35.4. Hope I've got this in the right spot. Yep. Oops, too high. I'll fix. There we go. 25.4. And 26 years is 36.2. Okay, so there's my scatter plot. So it definitely looks like a linear relationship. So we will draw the line of best fit. Now be careful when you're drawing a line of best fit like this. What should I do at the very left of my graph? So let's zoom in a little. What should I do here? Should I really touch the graph there? Well, the problem is that we don't, because of this fold, we're not actually looking at what would normally be called a y-intercept. So I'm going to push my graph a little bit forward just so that I'm not touching the line, because with that fold there, it's not clear necessarily what's going to happen. So I'm just going to do that. So there's the trend of the data, and now I want to find the line of best fit. Now in this case, I did happen to go through 2 points. I went through this point here and this point here. So I'm going to use those 2 points and find the equation of this line. So the first step in finding the equation of the line is finding slope. So here I'm calculating slope using these 2 points, and you'll see because of the decimal value, I've turned the entire slope into a decimal. So now I know that population equals slope times t plus b, and then I'm going to find the y-intercept. So here I've substituted in a point and found the y-intercept, or in this case the p-intercept, and that gives me this algebraic model for the line of best fit. And to use it to predict for the year 2036, let t equal 36 and substitute it into the equation.